Yeah, perfect.
All right.
Right.
Okay.
Floor is
You may
yours.
you may call me by Georgina. I think that's the one that I'm used to be called. Okay. Hi, everyone. Thanks so much for this opportunity. I'm going to share my research as well as some stories along the way. And my talk will be light, just an overview of my research. But if anyone is interested for details, please reach out. Okay. So just a bit of myself. I'm originally from Madagascar, the home to some of the world's most unique flora and fauna, so mainly lemurs and baobab. I did my undergrad studies in pure mathematics at the University of Antananarivo in the capital city of Madagascar. About 11 years ago, I received a scholarship to attend the AIMS program based in Muizenberg. I'm pretty sure most of you know about AIMS, but in short, it's a center for postgraduate training, mathematical sciences, for students across Africa. And at that time, the program was split into 3 phases, where the first phase consisted of a skill phase, where students have the opportunity to enhance their computing skills, communication skills, and problem-solving skills. And the second phase is the main review phase, where students choose courses to participate every 3 weeks. And the last phase is the project phase, where students work on the selected topics. And during the review phase, when I did AIMS, among the proposed courses to be selected was the Mathematics Industry Study Group, which was held at WITS in January 2014. And I chose that one and went to WITS for 2 weeks. I'm not sure how many of you is familiar with this workshop, but it's a 5-day workshop at which academic researchers and graduate students work collaboratively with representatives from industry on problems that are submitted by local industry. And one of the problems presented by local industry at that time was the cutting problem in the glass industry, which I took part in. So in short, the problem consists of minimizing cutting wastage so that customer orders are satisfied, subject to various requirements, as well as resource availability. And it was an interesting problem, but I must admit that at that time, I didn't really understand what was going on. But I enjoyed the experience, very grateful for the opportunity, and especially the exposure, because I had learned a new field, which I didn't know before, which is operations research. So this diagram represents the field quite nicely. It shows the various steps the field entails. So you are given a real system. A real system could be the dynamic graph of species in ecology, or the investment portfolio in finance, or the study of drugs intervention to patient in biomedicines, or else. And one need to identify decision problem, then define the scope of the problem, build a mathematical model, develop appropriate solution approaches, and then implement and test the model to the data. Once that's done, can conduct a sensitivity analysis and implement a solution with respect to the real system. And this tickled my interest, and I browsed around for an opportunity to get scholarship to pursue my study in the field. And luckily, I received a scholarship and found a supervisor and did my master at UCT on decision support for the production and distribution of electricity under load shedding. Load shedding was quite a hot topic at that time, and my supervisor and I thought, okay, it could be good to attempt applying simple operations research technique to model load shedding scheduling. So I managed to do that with my master. It was very interesting, and I wanted to continue my study in the field of operations research for my PhD. But I still have the cutting and packing problems in mind, so I decided to pursue a PhD on that topic at Stellenbosch. And my cutting and packing journey started from there. So just a simple explanation of what cutting and packing problem is about. So you are given 2 sets large objects and small items. The problem consists of solving combinatorial problems in which you have to select some or all items and assign each of these to position in one of the large objects. And you also need to take into consideration geometric constraints, relevant to the problem that you are tackling. And the goal is to minimize waste or maximize profit. This problem finds applications in many real-world problems, and mainly in logistics, such as pallet loading, container truck shipping, and even in cloud computing. And it has been researched for many decades and still quite a hot topic at the moment. I completed my PhD in 2018 and accepted the position at the Department of Statistical Sciences at UCT in 2019. Despite being courageous, I was stuck with my research for a couple of years. My first year at the department was just an adaptation to the environment, focusing on my teaching, no research at all. We all know the challenges and difficulties, related to the teaching activities. Then COVID-19 pandemic hits us, and a new system in terms of delivering lectures emerged again. I need to adapt to that new environment, and my research was put aside. And in 2021, a new chapter of my life started with my little treasure being part of my journey. So now, years pass since my PhD completed. I haven't done any research at all. So then towards the end of 2021, I told myself that I need to find a way to get my research going. I'm no longer a student. I'm supposed to supervise students, supposed to lead a research or a team. And then I spent some time during my maternity leave thinking about research, compiling ideas and topics that I can propose for honors or master students. And I also did some grant hunting. I needed, because I told myself that I needed to secure funding to attend conferences and push myself to do research. And in 2022, I was part of the Pathways to a Successful Academic Career program cohort. It's a very interesting program which provides participants with different opportunities and pertinent information regarding academic career. And among the important part of the outputs of the program was, the submission of research and teaching portfolios. And that has helped me a lot in terms of writing research proposal and also compiling grant application. So my confidence has grown a bit, and I applied for various grants with the aim to boost my research. And luckily, I received quite a few last year. The Tutuka grant, I'm in the middle of the project at the moment. The IMU CDC grant, IARU grant, which helped me to do a research visit and attend conferences during my sabbatical leave in the first semester this year. And I also managed to get a few students to be on board. That's the difficult part, but I'm trying hard. Yeah. Okay, so my main research projects focus on different aspects of cutting and packing problems, looking at deterministic case, multi-objective setting, and stochastic version. So I will briefly provide an overview of each of these projects, but in case you need more details, feel free to contact me. I'm open and happy to embark in a collaborative journey, student supervision, and especially if there is any opportunity to work with people from industry. All right, so the first two projects on deterministic and multi-objective problems are part of my NRF Tutuka project from 2023 to 2025. So the deterministic case focuses on finding lower and upper bound solution to the problem. In fact, most of real-world problems are complex, and it's rare to find optimal solutions. Therefore, one needs to compute lower or upper bound solution of the problem that are satisfactory and quick to obtain. And the trend of research in this respect consists of gathering data, design appropriate models, develop algorithms or solution approaches to solve the problem, and finding the appropriate software to use, and then implement and conduct analysis of the obtained solutions. Yeah, so that's like a typical trend of research in the field of cutting and packing problems. Another research direction is the reverse, which has emerged about 10 years ago in the context of cutting and packing field, and has become more popular now. So it's about algorithm prediction. So instead of developing tailored algorithms for any type of problems that arise in practical applications, the idea is to train existing algorithms with respect to problem instances or data and predict on the best performing algorithms that can be used to solve new problems. And on top of that, the algorithm footprint is determined in respect of the instance space. That means the study of why, where, and how algorithms perform well or bad on the instance space. One of my students is working on this, but just to give you an idea, so you are given the data, can plot it, have the instance space, then extract features from the data, and then study the algorithm performance with respect to the data, the problem instances, and then compile the algorithm footprint. All right, and then the multi-objective case concerns the extension of the single objective deterministic problem to account for different objectives pertaining to real-world problems. So to give you an idea, for example, during the packing process in parcel or last mile deliveries, beside the customer requirements, one needs to take into account the loading time, the delivery time, the load balance, the characteristics of all parcels, and many more. And some of these requirements are conflicting and need to be modeled in the form of multi-objective setting. And one of my master's students is currently working on a particular type of this problem and investigate the use of multi-objective framework and algorithms to solve the problem. But I want to say that the multi-objective cutting and packing problems are not popular in the field, and there are more room for research and investigation in case anyone is interested. All right, and then the last project on stochastic problem is kind of new project that I started to investigate from last year. I had the opportunity to visit two professors from the University of Pompeu Fabra in Barcelona and the University of Copenhagen in May and June during my sabbatical leave to start collaborative research on this project. The idea is to further extend the deterministic version of the problem to account for uncertainty pertaining to the problem. So example of the source of uncertainty include unknown demand or changes or fluctuation of profit of items and many more. And actually, it's not a new research area, but the idea is to investigate new modeling approaches and include other aspects to the problem. And example of application is in the third-party logistics. I have one student working on this, but yeah, need more if there are students interested to work on this one. All right. I think that's, in general, like an overview of my research. But I would like to end my talk with this slide, which is a nice peek showcasing the richness of the field of operations research. Though the field is not very famous and not very well known, I'm not sure, maybe because of the name, but it's worth pointing out that the field is rich and it's linked to many disciplines. So in short, OR deals with the development and application of analytical tools to improve decision making. So it makes use of data science, computer science, statistics, probability, optimization, to improve and operate real-world complex system in the best possible way. So as long as the system involves decision-making process, we talk about OR, and it can help researchers to improve decision-making. All right, I think that's it for my side.